Hello once again. We are back with another tutorial for the game Keep Talking and Nobody Explodes. Today we are looking at the module called Parity, and this is a fairly simple module. We can see it's got a little display window here, which we need to read to solve the module. We have two lights here, which we can toggle on and off. And over here on the right is the submit button. We have to submit that when these lights are in the correct state, either on or off as they're supposed to be, in order to solve the module. So, the tricky thing about this module is that we have to take a look in the manual over here and understand what it means to talk about the parity of a string of numbers like this, right? So every letter is assigned a permutation, a way of arranging the numbers 1, 2, 3, 4. And we have to be able to figure out what it means for that permutation of numbers to be either even or odd. All right, and so the manual sort of gives a way of explaining this. I'm going to start by actually explaining it a slightly different way, just to give a different perspective on the way you can sort of read this module, but you can solve it in either way, and I'll talk about both of those. So let's look, for example, at the letter that we have here on the module, which is a P. So that corresponds to this string of numbers 4132. So I'll just add those into my notepad here, 4132. And the idea is I want to compare this to the string 1, 2, 3, 4. Right? Obviously the string where 1, 2, 3, and 4 are in the correct order. That's sort of our starting point. And now I want to imagine how many times would I have to swap numbers around to get to 4132, right? So if I just swap two numbers, like I swap the 2 and the 1, that's one swap, right? One change. And then maybe I swap two more numbers, I swap the 4 and the 2, and ta-da, I have now turned this into 4132. And so if you were counting along closely, that took us two swaps. So, when we talk about the parity of a string of numbers like this, of a permutation, we're really just talking about the parity of the number of swaps that it took us to get there. So in this case, two swaps, therefore this counts as an even permutation, or an even string of numbers, if you want to think about it that way. And this module is all about comparing the various strings of numbers and checking whether they are even or odd, and then comparing the numbers themselves, some numbers themselves to each other, checking whether they're even or odd. And you just have to see, do they share the same parity, the same evenness or oddness, or not? All right. So, yes, that's how you can read one of these strings in the manual and see it as either even or odd. And there's a whole bunch of math that goes into what that even or oddness actually means, but all we really need to know is it the number of swaps? And is that number of swaps even or odd? So just for another example, let's look at, 2431, right? Let's say we had the letter G somewhere that we had to look at, 2431. We could get there from the string 1, 2, 3, 4 by again swapping the 2 and the 1 to start with. Now we swap the 1 and the 4. And that has turned our string into 2431 in, again, two swaps. So that would mean that G, this string 2431 corresponding to G, also has an even parity. And so when it comes down to comparing things, right, then we would say that G and P have the same parity as far as this module is concerned. Both of these are an even number of swaps to get to them, so they are an even parity. All right. And that's all we have to do. That's the only thing that's really difficult about this module, is understanding those swaps on these strings of numbers. And just to have a third one to compare to, let me look for one that I'm just seeing even ones all over the place. Let's look at B here, right? So B is 3421. So if we started at 3 and 4, 1, 2, 3, 4, how could I turn that into 3, 4, 2, 1? Well, I'd have to swap the 1 and the 3 to get the 3 in the right spot. Then I could maybe swap the 1 and the 2 to get the 2 in the right spot, and then I could swap the 1 and the 4. So that was 3 swaps total. So that means B is an odd permutation, has an odd parity as far as this module is concerned. Also as far as group theory is concerned, but that's for another video. So this 3, 4, 2, 1, this has an odd parity to it. That would be a different parity from G and P. Right? And you can see that, later on we're looking at, does the sequence of the letters share parity with the sequence of the displayed letter, right? That's all we're really looking for, is do they have the same parity or not? And so there's a lot of information that we can sort of forget about, like the fact that this one took exactly 3 swaps or this one took exactly 2 isn't really important. All we care about is the odd number of swaps here and the even number of swaps here. And since we only care about comparing, this is also the other way that the module describes how to check whether 2 of these strings share parity or not, is we could actually just put the 2 side by side. So maybe I want to compare B and P to each other, 3, 4, 2, 1 and 4, 1, 3, 2. And let's say I want to turn 3, 4, 2, 1 into 4, 1, 3, 2, again by making a few swaps. Well, then I would swap 2 and 3 maybe, and then I would swap 1 and 4, and then I would swap the 3 and the 1. So that took 3 swaps to convert those back and forth. So an odd number of swaps means that B and P have a different parity to them. You can sort of imagine it as like an even number plus an odd number is an odd number. So since we had to add an odd number, that's going to switch whether B and P are even or odd, right? Going from B to P took 3 swaps, so that will change the parity of this permutation. So B and P have opposite parities. They do not share parity to each other. And so that's what the manual is actually talking about here. If you have to swap elements in the sequence to get to the other an even number of times, they share parity, right? So in other words, if it takes an even number of swaps to get from this string, 3, 4, 2, 1 to this string 4, 1, 3, 2, then they have the same parity. But if it takes an odd number of swaps to get from one to the other, they have a different parity. All right. So you can do this either comparing the parities directly to each other, or by just calculating the parity of each one on its own and then comparing those. And so then that second one is the one that I prefer. Now that's because I'm a little bit more familiar with the even and odd thing. It's a very esoteric math thing that if you weren't a math major, you probably never studied. But so if you're not familiar with that and you would much rather just compare the things directly, that's perfectly fine. Again, they're both completely equivalent to each other. Another nice thing is you sort of can't make wrong choices when you're thinking about how do I swap to get from here to here. Like maybe you make some silly choices and it takes me 7 swaps to get from here from B to P instead of only 3. That's fine. It will always be an odd number. As long as you're counting correctly, you absolutely cannot get it wrong. So it's not like you have to worry about doing it in the absolute least number of swaps or anything like that. The parity, the even or oddness, will always be correct. So here is the way that we now actually solve the module now that we understand all of that even and odd stuff. So we first look at the pair of a letter and a number that are on the module. So that's a P and a 6. And so as we saw before, the P is an even permutation. It took us an even number of swaps to turn 1, 2, 3, 4 into 4, 1, 3, 2. So I'll just mark that as even. And of course, 6 itself is an even number. Then the manual says each LED has a letter number pair associated with it, obtained from the serial number. So the third and fourth characters, we know that will always be one letter and one number. Those go with the left LED. And the fifth and sixth characters will also be another letter and a number. That's associated with the right LED. So if I just go for my serial number here, where are you? There we go. So the third and fourth digits are M5. And then the fifth and sixth digits are X8. And so the M and the 5 go with my left LED. The X and the 8 go with my right LED. So we can do the same thing here. Let's see, the M permutation 2314, that would take 2 swaps, so that's an even, and of course 5 is odd. The X permutation 3142, that's going to take 1, 2, 3 swaps, so that will be an odd permutation, which means we write that as odd there, and of course 8 is an even number. Now, for both LEDs, we note down the following: whether the sequence of its letter shares parity with the sequence of the displayed letter. So we just compare this letter, this letter's parity, even, to the original letter's parity, the letter off the module, which is P. So the first one is a match. And then we compare whether its number shares odd, even parity with the displayed number. And 5 says this, rather, on the left LED, this 5 does not match parity with the evenness of the 6. So we have one match, one non-match. And same thing with the right, we can check the odd does not match the even up here if we compare the letters. So that's a non-match. The even does match the even, so that is a match. And then the states of the LEDs are determined as follows. The left LED must be on if these conditions are of the same parity, either both apply or neither does. So this is a match and a non-match. So those two are different from each other. That means the left LED must be off, right? If these two were the same, either two matching or two non-matching, we would turn the left LED on. But as it stands, we just want to leave the LED off as it is right now. Whereas the right LED must be on if these conditions are of opposite parities. So since we have two different ones here, that means the right LED wants to be on. If you want to think about it this way, if you are familiar with the logic gates, we would just apply an XNOR gate to the left pair here and an XOR gate to the right pair. And then just turn the lights on or off, depending on whether those gates apply to evaluate to true or false. So this tells us that the left one should be off, the right one should be on. So if I just click the submit button with the lights in those states, that will go ahead and solve. And so I've got a second one here on the bomb. Let me just go ahead and do this real quick. We'll just change this to Q0. Of course, 0 is even. Q3241, that is an even permutation there. So this is going to work out exactly the same way as before. The left LED, the letters match, the numbers don't. So that will be one match, one non-match. That means we leave the LED off. On the right LED, the letters do not match, but the numbers do. So one non-matching, one matching. That means we turn the right LED on, and that will solve in the exact same way. So there you go. It's a pretty easy module once you get used to doing this little bit of counting that you have to do about the permutations and whether they are even or odd. Just be sure you've got your, are my parities the same or different? Note those down carefully and then translate those into what you're supposed to do with the left and right LEDs, and you should be fine. So thanks for watching. See you next time.